Okay, welcome to this deep dive tailored just for you. Today we're tackling artificial intelligence and machine learning.
hmm
You sent over some great material, and well, our mission is to pull out the really key ideas, the interesting bits, without getting too lost in the weeds.
Exactly. And it's important, right? Because AI and ML, I mean, they aren't just for specialists anymore. They're kind of everywhere.
Yeah, under the hood of so many apps and things we use daily.
Right. So getting a basic handle on them really helps understand where tech is going.
So let's start broad then. Artificial intelligence, AI. What are we actually talking about?
At its core, AI is this idea, this goal of creating machines, systems that can do tasks that normally require human intelligence.
Like thinking, problem solving.
Yeah. Or learning, making decisions, understanding language, that kind of thing.
Okay, and I know there's this distinction, narrow AI versus general AI.
Right, that's a really useful way to think about it. Narrow AI, sometimes called weak AI, is what we mostly have now. It's AI designed and trained for one particular task.
Like a voice assistant, or maybe those streaming recommendations.
Exactly. Super good at that specific job, but you can't ask your Muji recommender to, drive a car.
Makes sense. And general AI.
That's the more sci-fi idea, really. A machine with the ability to understand, learn, and apply intelligence across a whole range of different tasks, much like a human.
So adaptable intelligence.
Pretty much.
Yeah,
It's still largely theoretical, a long-term research goal, but narrow AI, as you said, that's very much here and now.
got it. Okay, so if AI is the big picture, where does machine learning, ML, fit in?
Okay, so ML is a subset of AI. It's one of the main ways, probably the most important way right now, that we achieve AI.
So it's a technique.
It's a technique, yeah. Instead of writing explicit step-by-step instructions for a computer for every single possibility, ML allows a computer to, well, to learn from data.
Learn by example, sort of.
Precisely. You show it enough examples and it starts to figure out the patterns or rules on its own.
And there are different ways it learns, right? I saw supervised, unsupervised.
Yes, exactly. Supervised learning is probably the most common.
Yeah.
You train the model using data that's already been labeled.
Like showing it pictures tagged cat or dog.
Perfect example. You give it the answers, essentially, during training. Then there's unsupervised learning.
No labels this time.
Right. The machine looks for patterns and structures in the data all by itself. Maybe finding customer segments you didn't know existed.
Interesting. And reinforcement learning, that sounds different again.
It is. Think of training a pet, almost. The AI agent tries things out in an environment, and it gets rewards for actions that lead towards a goal and penalties for ones that don't. Trial and error.
Like robots learning to walk or game playing AIs.
Exactly, those kinds of things. And you see ML, as the material highlighted, in spam filters learning what's junk, or even in complex systems like self-driving cars interpreting sensor data.
So AI is the goal, ML is a key method. How do they practically work together? What's needed?
Well, it almost always starts with data. Lots and lots of data, often called big data.
Yeah.
Then you need an algorithm. A machine learning algorithm is like, the set of rules or procedures the computer uses to learn from that data.
The learning recipe.
Yeah, that's a good way to put it. You use this algorithm to train a model.
Model and training. We hear those a lot.
Right. So training is the actual process of feeding the data into the algorithm so it can learn those patterns. The model is the result, it's the program, the artifact, that has learned and can now perform the task, like recognizing cats or predicting house prices.
And how do you know if it's any good?
That's where accuracy comes in.
Hmm.
You test the trained model on new data it hasn't seen before to see how well it performs.
Gotcha.
There are other concepts too, like overfitting. That's when the model learns the training data too well, including its noise or quirks, and then it doesn't generalize well to new data.
So it memorized the test, but didn't really learn the subject.
Kind of, yeah.
Yeah.
And you'll also hear about neural networks, which are algorithms inspired by the structure of the human brain, often with many interconnected layers.
And deep learning.
Deep learning basically is using these neural networks, but typically ones with many, many layers, hence deep. It's allowed breakthroughs in areas like image and speech recognition. Oh, and computational power is crucial for all this training, especially deep learning.
Right. Processing all that data takes serious muscle.
Definitely.
Okay, let's quickly recap then. AI, the broad aim for machine intelligence. ML, a core technique where machines learn from data using algorithms.
Supervised, unsupervised reinforcement learning are different styles of that learning.
And it all hinges on data, algorithms, training, resulting in a model whose performance we measure.
You got it. Concepts like neural networks and deep learning are powering some of the most advanced stuff.
What strikes me is how, like you said at the start, these aren't just abstract ideas anymore. They're woven into our daily lives, often invisibly.
Absolutely. From search results to fraud detection to medical image analysis,
Yeah.
it's really becoming foundational technology.
Which leads to a really interesting question, something for you to think about. As AI and ML become even more integrated, even more capable, what new possibilities or maybe even challenges do you see emerging in your specific field or your own areas of interest? Where do you see this heading?
Thanks for watching FutureBond's AI Humans. What's next? Let us know your thoughts in the comments. Don't forget to like, share, and subscribe for more AI insights. See you in the next episode.